us. Distance between the two disks also is known to us, that being same as 24a. A being out, this is what being given to us. Distance between the two disks also is known to us, that being same as that of this. Excuse me for the drawing. Same as that of this, both being L. What all being asked, I'm not going into the detailing of what all being asked. I will rather restrict it to one at a time and will ask you to write the dynamics of this particular notation which I have shown over here. First, get me dynamics of this notation. What can you say about the center of mass, velocity of center of mass if being asked here? What is your take on velocity of center of mass given to us that the disks are in the state of rolling without slipping and omega is the angular speed about this line? Omega is the angular speed. They are rotating, going away from us, let's say. So if I am to curl my finger, we get direction of omega, it being in this direction.
Your camera is not aligned.
Okay. This is omega. This is omega to us. Is it fine now?
Yes.
Okay. This is omega to us. I simply did curl my finger. Curling my finger is getting the direction of omega, which is this way. Let me ask you one at a time of the four options which we do have. Let me first go with what is omega of center of mass? If I'm to get omega for center of mass, how will I locate a center of mass, which is easy for you to gauge? Second, how will I get velocity, angular velocity of center of mass?
So
So
angular.
let's do it afresh. Let's not go by what being on internet suggested. I would wish you to apply your own faculties and get me an answer to it.
So finding the center of mass itself is pretty trivial. And once you find the
Yeah.
center of mass, you can find the velocities of omega r.
Let's say I got center of mass position. It's simple over here. We will write m into whatever, and then from there you'll be able to m into x. This is L given to us. So if I take from this point, we get it as m into L plus 4m,
4m times
right?
2l.
4m
5.
times 12 of L whole divided by m plus 4m, right?
Yeah.
Which is
Yes.
5l, correct?
Yes.
So we get from here 8 plus 1, that is 9l by 5, right?
Yes, sir.
Correct? So 9l by 5 from here 9l by 5 means what position we are to get somewhere over here. It will be 9l by 5 twice of L minus 9l by 5 or L 9l by 5 minus of L. We'll be getting it as 4l by 5, right?
Yes, sir.
So this will be 4l by 5 to us, and this will be L by 5. Fine. We got position of center of mass. We also got values for cos theta and sin theta. We may be using, I'm just into preempting the values because we will be using in due course of time. This is theta. Theta, if gotten A known to us, L known, we'll be able to get use or make good of this theta value later, as did indicate. So cos theta and sin theta are gettable from here. Tell me how will you get what I am to find, which is center of mass as my first ask. Center of mass omega.
Omega about which axis exactly?
Omega of center of mass, if I'm to get omega, it'll be about this axis, which is perpendicular to the axle taken over here. If we assume this to be the axle and perpendicular to the axle, this is the direction in which I wish to get omega for center of mass. We can mark it as alpha, or let's say I'm marking it as omega, capital omega. Yeah.
Okay. So we know the
Hmm.
so we know the angular velocity with which the entire setup is rotating.
Yeah. It is rotating about this point, which is
Yes.
omega. Wait, yeah.
Using uh, using that, we can find the velocity of the center of mass, right?
Okay, we get right. You're right. So velocity, let's do it. Velocity of center of mass then from here will be as we got the value as 9L by 5, right?
Yes, 9l by 5 sine theta.
So
times
If
omega.
I'm to if I'm to ask you about why should we be beholden by center of mass? Because if I'm to get it easily by any other point,
Yeah, that you can do
it'll
that
be
too. So you
same
can
as
just do L
it.
sine theta
Uh-huh.
times omega. That should get it to the velocity of that point divided by L.
So of this point, Vasudev, this one,
Yes.
we know that they're rolling without slipping.
Yes.
So of this point, if I'm to get velocity,
Hmm.
velocity of this point is easily gettable as v is equal to omega known to us and known to us a, right?
Oh, okay. Yeah, if you
Isn't it?
had an expression for A. All
This
right. All right.
point.
Okay. Fine.
It'll be easier, isn't it?
Yes. Sure.
Or you take this point
I,
from v is equal to r omega state, we'll be able to get v easily for these points,
yes.
right? Once you have gotten v, then we can get omega from here as well, right? Omega prime, let's say, or capital omega, isn't it?
Yes.
Check it out.
Yep.
So, what shall we do for it? We got v is equal to r omega known to us, right?
Yes.
So, can we write it down as omega a is equal to what shall I do? Omega into L, capital omega into L, right?
Yes.
It should be equal to omega into a, right?
Yes.
And then from here, what do we get is capital omega, which is omega a and L given as 24 under root a. We got it as omega under root of 24, right?
Yes.
Okay. When the question was asked, what will be the z component? And incidentally, this was gotten by taking this angle same as this is an obvious mathematically, right?
Yes.
This angle and this, they'll be same. This being our z axis, we are just to multiply with cos of the angle theta, right?
Yes.
So if I'm on my liberties to write it as omega z, we will get it as omega under root of 24 cos of the angle theta, right?
Yes.
Cos of the angle theta, cos theta can be easily from here extrapolated and let me know what will be cos theta from here, dear. This angle is 90, right? This one is 90.
Yes.
Visible?
Yeah.
Okay. So this is 90 to us. We'll get from here cos theta
L
based by
by square root
hypotenuse. Right.
L square plus A square.
Yeah, okay. So what will be L by?
Under root L square plus A square.
Okay. So cos of the angle theta is L divided by under root of, which is 5a, right?
Yes.
If I write for L is known to us as under root of 24a, right?
Yes.
L is known as under root of 24a and L divided by, what did you say? Come again?
L by 5A then.
5a, okay, which makes this boil down to omega by 5, right?
Yes.
Isn't it? Can there be any other way out, dear? Easier than this? Think about it. If we do have, there can be many a way. I'm getting you just one of the many. So this is omega by 5 to us, which was an option. So this certainly is a pick. What about L of center of mass? About O. Find angular momentum of center of mass about O. How will you go about it? L of center of mass about O. Pretty simple. Mind you, in the question, the option was to read L of, that is angular momentum of center of mass. So if it is angular momentum of center of mass, which we missed by many a YouTuber, angular momentum of center of mass means what to us? We have to assume that there is a point which is positioned at center of mass of system, right there.
Yes.
There's a point which is positioned at center of mass of system, and mass of this point is an assimilation of the mass which the system comprises of, right?
Yes.
Different part of system comprises of. So there are two disks over here. We'll assume that entire of the mass is concentrated out here. So mass of this point will be 5m to us, right?
Yes.
And then we can use ml square into omega to get L, or can use R cross MV, right?
Yeah.
As it is a point, you either go by R cross MV as ml square being used everywhere. So I prefer going by something which is new. I'll assume L equal to R cross MV being more to me relate here. Okay, so this will be what to us. Nonetheless, it remains, equation remains R as it is, M as it is, and V is nothing but R into omega. So it boils to MR square into omega. We know M will be replaced by 5 small m, let's say. R will be replaced by, now this distance being 9L by 5, right here?
Yes.
Visible?
Hmm.
So 9L by 5 whole square, and then whole multiplied with
Capital
omega,
Omega.
right?
Yeah.
Whole multiplied with omega. So this is omega 2 is. Okay, do check. All good?
So could you uh, move the camera a little bit to the position where you
Right.
just wrote it?
Now, there is one point which I would like you to
So
emphasize on.
wouldn't it be capital Omega?
That is what I was to ask. This is the point that I wanted to emphasize on. What should I write over here?
So over.
MR is square into omega, right? So
Yes.
which omega? Of course, the omega with which this point is moving. So it should be capital omega, right?
Yes.
Therefore, we will divide it by 5, right?
Um,
Isn't it? Capital omega is omega by 5, right?
yeah. Yeah.
Can we do that?
Hmm.
No, we cannot, dear. Capital omega is not omega by 5. Omega z is omega by 5, right?
Oh, yeah. My bad. It's just a Z
So
component. Yeah.
capital omega is omega
Yeah.
under root of 24, right? So this
Yeah.
will be under root of 24. Gotten?
24. Yes. Got it.
Okay. There was an option which was very close to it, which made us imperative to look into it. There being an option with 24, under root 24 being a miss. I think you can check for the option you'll get for yourself, right?
Yes.
So we had to be very careful. They went a tad bit nasty over there by just removing under root of 24. Rest all were a match or ditto.
Yes, sir.
Okay, so this was the other us which did match. There are a few more terms, and that was what will be there. So this one is simple. I would wish you to do this. What will be L about this axis or about center of mass? What will be L for the system about this axis? So there is not much I into omega idea.
Yeah.
I can be gotten for this MR square, MA square by 2, for this 4M into 2A square by 2, correct? They
Or
will
like
add,
times Omega.
yeah, in times omega, right?
Yes.
Okay. So this was one question I wanted to deal. The other which I want to is also of a truncated cone kind of. It was in fluid mechanics. This is being given to you. It was 2012, if I am recollecting it correctly. And the meniscus being introduced. This angle, or the apex angle as they call, was given to us as alpha. Apex means it was up to this point, but they extended it with dotted line to show that this angle, this total alpha. I'm marking differently here, alpha by 2 for this and alpha by 2 for this. I hope it is visible.
Hmm.
Okay.
Yes,
So
it is.
alpha by 2. Okay, alpha by 2, height being known to us, let's say this being the case to this point. So you have to get H over here. Or S, or a relation between H and S. Theta was given to us as the angle of contact. Theta being the angle of contact.
So
We know
what's
that pressure differential. Yeah, come on.
what
Carry
is
on, carry
S?
on. S is surface tension, or T is surface tension. H is the height up to which it rises in this truncated funnel. The
Okay.
liquid rises. Alpha is the angle, apex angle, as they call, and T or S is the tension notation. So how we will go about it? The basic formula.
Actually, it's been a while since
Think about,
I've
think
revised
about
this.
it. Acha, a revision. Okay. So in that case, what is the differential pressure? For simple case, if you are able to recollect, let me ask you for this case. Uh, let's say this is being placed. Let's recollect because we don't have much of
Yeah,
time left.
we used to say that the pressure at a point just below the meniscus would be PAT minus 2T by R, right?
Hmm. Correct.
Hmm.
So up if this point we are to mark pressure atmosphere as P naught,
Hmm.
just below of it, let us say it is P, right?
Yeah, that would be
And then by dynamics, yeah.
yeah that would be P naught minus 2T by R. Pressure at the very
So,
bottom would be all of that plus rho GH.
so at this point also it is to be P, right? P naught, right?
Yeah.
It is in level. So
Yes.
this side will also be P naught, and if we are going by the pressure dynamics, statics rather, then we will write equal to, or P naught is equal to P plus rho GH, right?
Hmm.
Okay. From there we get P naught minus P is equal to rho GH, right? This was pressure equation, correct?
Hmm.
Okay. Also, by sphere, if it is part of sphere, larger sphere, and the contact angle is theta, then we used to write something in terms of tension, surface tension, right? Because as per surface tension, if it is a sphere, we can mark as P minus P naught, rather P naught minus P, that is the additional pressure, should be equal to 40 by R, correct?
So 40 by R?
40 by R or 2T by R?
So 2T by R, right?
2T by R. I'm to, by the way, come to this also. How do we get 2T by R? And what if we are having a sphere with two radii? If there's a sphere which is slightly deformed and we have got two radii to apply, as we call Gauss to Q. So what we do, how do
There's
we change T by R?
there's a formula for that, right? T times 1 by R1 plus 1 by R2. Or 2T
T
times 1 by
times by R1 plus T times by R2,
Yeah.
if you're having two radii. But how do we get to that formula is of import? So we'll try that out. Of course, we do change it to T by R1 plus T by R2. Okay.
Yes.
So we are now over here to equate rho GH to 2T by R, right? And this is what we get in general, right? Where R is what over here, not to miss. R is not radius of capillary tube. R is the radius of
Radius of
sphere,
curvature.
right?
The radius of curvature.
Yeah.
I see.
Yes, the radius of curvature, and that has got a relation to share with small r, right? Which is r cos theta is equal to small r, correct?
So could you just hold for a second? Your
Yeah,
screen's not very
certainly.
visible. It's, it's really blurry. I can't read a thing.
Okay, just a moment. Just a moment. Is it better? No?
No.
Better. Okay. Let me focus it.
I mean, you do have a graphic
Any luck?
tablet, right?
Any luck?
So no, I was just asking if you still had your graphic tablet.
Tablet.
Yeah.
Yeah, there is. I don't think it's charged. Is it charged?
Oh, maybe we can use that for next time.
Just a moment.
I
Just a
mean,
moment.
it certainly help if I didn't have to have my head cocked at 90 degrees for the entire time.
Let's see if it works. Otherwise, I'll be using tablet. Not working?
No.
Okay, then I'll connect with tablet. I'll be using a digital tablet. So I'm disconnecting Vasudev and connecting by uses of tablet.
Yes.
Okay. Yeah. Right. Good now?
Yes.
Okay. Just to use.
I still can't see a whiteboard.
Yeah. Just a moment. You'll have to allow, right?
Oh, I don't think I've disabled host controls. So
Okay. Okay. Just a moment. Just a moment. I think I've joined with a different
under
email ID.
activities, there's a panel called whiteboarding.
Yeah. Yeah. Just a moment. Just a moment.
Okay, thank you.
Jamboard isn't working. Is the Jamboard functional nowadays?
Currently it is. It's going away
Okay.
in October, they say, but we can use it for now.
Mm-hmm. I think it's posing problem. Just a moment. Can you see the screen? Can you have the screen?
Yes, I can.
Okay. Okay. So this was the case, I presume, and given to us this case, truncated one, this angle as alpha by 2, and the height in accordance of the meniscus being h. So this was the case with us. H being us, given to us surface tension S, and angle of contact theta. How shall we go about it? Just now we got to know that rho gh in general can be equated to 2t by r, capital R, where r is the radius of curvature, as you did mention. It is equal to 2t cos of the angle theta by small r being the radius of capillary tube, right?
Yes.
Okay. What to do in this case, dear? How do we go about this question? Yes, we are
So
having two.
I think what we
Yeah.
can do is draw an imaginary tube that is perfectly cylindrical,
Mm-hmm.
and
Okay.
so that its
I'll
bottom.
do that for you. This is the case, perfectly cylindrical, right?
Yes.
Okay. And then would you ask me to draw a sphere, hemisphere? Shall I? So as to get contact angle 0.
Okay.
If the contact angle is 0, then we get a hemisphere, right?
Yes.
So let us take the contact angle 0, which is what I'm taking over here. And then this gets us the contact angle 0 fine. What about this case? In this case, what should be the contact angle? Given to us, contact angle is theta. Let's say in this, the case which I have shown over here, Vasudev, had this being truncated, had this being with a slant, right?
Mm.
Had this being with a slant, then I would have got this tilted by an angle alpha by 2, correct?
Yes.
Okay. And if the contact angle were theta, then the total angle will sum up to theta plus alpha by 2, right?
Yeah. That's where I was going.
Yeah, exactly. So what we have to do is an obvious now. Instead of theta, we are to write theta plus alpha by 2, right?
That's it. That
That's it.
solves the question. Okay.
That is what the question says. It was 2012 one, not much, but it was just a change, a positive change from the rotate. That's the reason I did pick on this one. One I have, simple one, though again, is anecdotal evidences that we go through in our day-to-day life, so it matches good with it. The question says, if we could jot it down quickly. The question says two long capillary tube. Yeah, I'm letting you know the data. Two capillary tubes, right?
Yeah.
Diameter of first one is 5 millimeter.
Mm-hmm.
Diameter of second one is 4 millimeter.
Mm-hmm.
Are held vertically inside water one by one.
Okay.
Okay.
Yes.
How much high the water will rise in each tube? How much high the water will rise in each tube? What will be the height of water in each tube? Given to us is, let's say, G, which is 10 meter per second square, and surface tension 7 into 10 to the power minus 2 Newton per meter. 7 into 10 to the power minus 2 Newton per meter. It comes straight from the one that we were into discussing.
Yes. We know that h is equal to 2t by r rho g, right?
Correct.
Um, now, if they're long enough, I think R will eventually be the same.
Okay. But given to you over here
No,
two
no, wait,
radii,
no,
right
sorry,
dear?
that was the wrong assumption. They have different radii, so they have different radii. How does the radius of the meniscus depend? Oh,
Yeah,
oh yeah,
yeah.
wait. So,
That is
small r
what.
is equal to capital R cos theta.
Yeah, correct. So we can say that small r, there are two small r given to us. One is 5, the other is 4.
Yes.
Yeah. So from there, if we are to extrapolate h1, h2 or relation between h1, h2, how we should go about it?
How does theta or small r or capital R vary with small r? That's the only question. How do we vary with
Let's
theta?
say that. Are you recording it, Vasudev?
Yes, yes, yes.
Let's say, Vasudev, that we are having a deluge case with. Have you ever met a situation in which you are trying to pour water or a liquid in a glass which has got up to the brim, yet you keep on adding water to it? What happens? I'm not going for the overflow case. I'm going for the case when it is about to deluge.
Yeah, the height goes a little higher than the height of the glass. It tries to keep itself
Okay.
wetter to a certain
Uh,
extent, and
let's say, let's say, okay, fine, taken, taken. Any other observation? Slight higher than the height of glass, okay, taken. Any other observation on the meniscus? Will it change or not?
yeah, it
Will the
the
meniscus change?
radius keeps decreasing till it reaches a minimum value, after which it just spills over.
So that's it. H1R1 is equal to H2R2, right? Right.
Um, wait a second.
Because, yeah.
Hmm.
Theta won't change, T won't change, G won't change, rho won't change, right?
Okay, I see. I see what this means. I see. H1R1
Right?
is equal to H2R2.
H2R2. This is an important derivation. H1R1 is equal to H2R2.
Got it.
Okay, dear?
Yes.
Okay, the last one which I want to end this class with is on calorimeter. Shall we go about it or shall we take the other day?
Can we do tomorrow? Just revise them down. Maybe it'll be faster.
Sure, sure, sure. Same here. Okay, we'll be taking it tomorrow in that case, right? And was it please do share the other one as well? Yeah, I don't know what's the reason. Is it playing in your device? The other video?
Yes, it is, and I checked the link. That one's working too.
Yes. Okay, if you may share it once more, we'll do a
So it
favor.
is it is a zip file. You know that, right? It's not video. It's compressed. You'll have to unzip it.
Yeah. See, I don't know. I'm getting a message. Maybe I'll have to try with a better network. I will try by 2 o'clock today. Nonetheless, this one also you can share, right?
Yes. One second. Could I just ask you a question?
Yes, please. Sure.
Why exactly do you upload these videos on a YouTube channel?
This is because there are few students who are to be beneficiary of these videos. They are not into lecture as of now. When they will join, at that time they need to go through it. So if it is
So
there already with me
I
as
just
data.
think if
Huh.
we are actually using this as a resource for somebody else, this is not the best way
Mm-hmm.
to do it because these classes are, I mean, in lecture format they're good, but when you're watching them as a video, it feels very bloated. I
Ah, that's
so
true.
so
That is an
the
assistance.
sir.
That is an assistance when I am into taking classes with them. That this is being played for assistance because with them also the classes are live. Let's say there are students who cannot join as of now, There are few students from different school, boarding school. They cannot join us of now. So when they will be on 23rd or 29th of May with me, then we'll be able to discuss with them. That's right. And it's an assistance. It's not that only video is what they are to check. That's the reason.
Sure. Yeah.
Okay.
Bye.
Okay, dear. Thank you.